Good day, students. We're going to look at the solution now to number 17. It's the last of your full response long answer questions from chapter 6 of your sample quiz that's found in book 3 of your ma1026 booklets. And we're asked to find a volume and surface area of a cone. Okay, volume and surface area of a cone, and we're given the slant height. Now the slant height is 8.5 meters. That's this here. That's the sometimes called lateral height, oblique height, but slant heights are very common, and we use the letter L. So we know L is 8.5 meters. We're also given a base with a radius of 6 meters. So we also have another dimension, 6 meters for the radius. Now, one we do not have, of course, is which one? Which is the one we don't have? We're missing the third dimension. What is it? The one we need is the perpendicular height, isn't it? And where is that in our diagram? The perpendicular height, of course, is this value right here. Height, remember, of a right, this is a right circular cone, is perpendicular to the radius. And heights, we use those values as always perpendicular to the radius, right, for these formulas. So we're going to have to find h, and then we're going to have to find the volume and the surface area. So 3 steps to this. But before we can do that, we need those formulas too. Before I get rid of those formulas, let's choose what's the volume and surface area of a cone. Now I see the volume of a cone right here. It's 1/3 the same as a cylinder, right? Cylinder is pi r squared h. Volume is 1/3 of a cylinder, right? The volume of a cone, I mean. So we need that one. Volume is 1/3 pi r squared times h. And the surface area of a cone is right here, because it's the surface area of the bottom circle plus the area of the curved or lateral surface. So that's the other formula we need. Surface area is pi r L plus, I'll use a capital L, plus pi r squared. Okay, so let's get rid of those formulas. Give us some room to finish this question. So the first thing I'm going to do, step 1 over here, I'm going to go find the height. I'm going to find the perpendicular height h. Now you'll see there's a triangle right there. I'll draw it separately just for a second. So we have this side here. You'll see it there, it's in blue, right? Then we have the height, and then we have, of course, the lateral surface. So inside that cone, right at the center base, okay, we got a right angle, and we have a radius of 6 meters, a perpendicular height we don't know, called h, and a lateral height or slanted height of 6.5 meters. So you can see right now we're going to have to do the extra step here and use what theorem? The Pythagorean theorem for right triangles to find the missing side. And we've used this theorem a fair bit this year. And the theorem states if you square the 2 legs and add them together, you'll get the hypotenuse squared, right? In other words, the square of the 2 legs is equal to the sum of the squares is equal to the hypotenuse squared. So, and some people write it using the word leg. So leg squared plus leg squared equals hypotenuse squared. Now we want to find a leg, right? So if we're going to find a leg, we're going to have to subtract, because this is the biggest side, right? The hypotenuse. So we're looking for a leg. So what's it going to, remember, when you're looking for a leg, you'll always subtract. Okay, so h squared plus 6 squared, the other leg, equals the hypotenuse squared, 8.5. So subtracting 6 squared from both sides, I get 8.5, subtract 6 squared. And you can do that right on your calculator. So 8.5, we're going to square that. And we're going to subtract from that 6 squared, which of course is 36. And we get a value of 36.25. That's h squared. That means h is equal to the square root of that, of course. And that will give you a value. Let's do it. Second function, square root, 36.25. It's going to, oops, I forgot, my 2 didn't come up. 5. It's going to be slightly greater than 6, isn't it? So it's 6.02, and to be a bit accurate, I'll keep that. So now we know the height, right? The slant height is 6.02. So we have all 3 dimensions now. So now it's just a matter of plugging them into formulas. Okay, let's do the first one. The volume here is equal to 1/3 pi times the radius. Now what's the radius? 6 meters. I'm going to square that times the height. We just calculated 6.02. So putting that in our calculator, I'm going to use the fraction. So alpha, green button, y equals, we'll bring up the fraction window, and it's 1/3, or you can just say 1 divided by 3, same thing. I need pi, so second function pi, open bracket 6, close bracket. We have to square that radius times the perpendicular height, which is 6.02, close bracket, and we get 226.95. 226.95. Now it doesn't tell us to round off. If we round to the nearest meter, it will be 227. And again, don't forget, volume is cubic meters. So there's the volume right there. The volume is 227 cubic meters. Now if we went again with significant digits, because our lowest number of significant digits is 1, we would technically have to write this as 1 significant digit, which would bring it down to 200 cubic meters. However, for the sake of a little bit more accuracy, I'll use it to the nearest meter, which is 227 cubic meters. So there's our volume. Now, surface area. Now, surface area starts again with pi times the radius times the lateral height. Okay, and the lateral height is 8.5, or slant height, times pi times the radius squared. Now we don't need the perpendicular height for surface area. Alright, let's plug that in our calculator. Second function, go get pi times 6 times 8.5. Add to that the area of the circle. Second function, pi times 6, the radius 6, close bracket, squared. Enter that, and we get a value of 273.32. And again, if I go to the nearest, say nearest meter, it'd be 273 square meters. But technically, if significant digits were asked, I would again have to go to the nearest 1 digit. So if you went with significant digits, you'd have to go to 300 square meters. Okay, so let's leave it at 273. So there's your answer for volume and surface area of a comb. That's number 17 on page 44.